Now we're going to look at the law of refraction, and we're going to look at it using different mediums. We're going to use glass, acrylic, and water. And how do we get water to do that? You go to Michael's and you buy one of these square things for $1 or so, or go to Goodwill, and it's very effective. The plastic is very thin, the amount of water is very large, so you'll get very close to the true value of water without having to do one of those complex devices. So the law of refraction states that N1, which is the refractive index, is going to be a function of the speed of light in a vacuum divided by the speed of light in a medium. The speed of light in a vacuum is a function of the permeability of free space, the ability of a vacuum to hold a magnetic field, and the permittivity of free space, the ability of a vacuum to hold an electric field. Now in the medium, it's based on the permeability of the material and the permittivity of the material. So functionally speaking, for most practical purposes, the refractive index will be a function of the dielectric constant that relates the permittivity of free space to the permittivity of the material, and the magnetic susceptibility of the material will be a function of the permeability of free space times the quantity 1 plus chi, which is known as the magnetic susceptibility. The refractive index of air is 1. The refractive index of water, if it's pure, is 1.33. And glasses can vary, and so can acrylics, but it's around 1.5. So what we see here is the rays in, let's say, air is in our case, and it's coming in, and the angle becomes smaller when it goes, let's say, into glass. Because if I traced it through, it would be here, which is what you saw. But it's smaller because N2 is greater than N1. So I want to give you an example of this. I have a big acrylic block here, and I'm going to turn off the light, and I'm going to shine this laser straight through, and I'm going to shine this laser at an angle. And you might be able to see it faintly, but you'll really see it when I turn off the light. So this is the baseline here, and this is where the ray comes out. Yes? But now look at where the ray comes out. You can see it clearly straight through, but when the acrylic block was here, it was at a different angle.